We are going to continue with the next couple of problems in section 7.5 of not just interpreting our confidence intervals for two population proportions, but actually finding them as well. We can go through and find our confidence intervals in the same method that we did in the previous section, where we check our conditions of the central limit theorem, find our standard error, find the margin of error, and then find and interpret the interval, all working through values by hand. We are not going to work through these problems by hand. We are simply going to be using Statcrunch to find our confidence intervals for these. So as we're setting up these confidence intervals, the key thing to think about is we're thinking about our comparison of P1 minus P2. So that means our confidence interval is technically our P1 hat minus P2 hat plus or minus M. As we're going through these problems, we do want to check our conditions. And we are actually going to work through our conditions in these next two examples, just because we want to see what happens based on what we're dealing with if we have two different populations. So we're going to talk a lot about our conditions and checking these. The process is still the same as to what we've done before, but we are going to work through the condition checking process for these next two examples that we're going through. At the bottom of this page is our steps for Statcrunch. Our steps for Statcrunch are very similar. We're going to go into Stat. We're going to select our proportion stats. Instead of selecting one sample, as we did back in section 7.4, we're going to be selecting two samples. We're still going to select with summary. We're going to enter the number of successes and observations for each population. Again, if those are not given, remember we can find those using multiplication. Right? Then we're going to select our confidence interval, make sure we enter our confidence level. Right? And then we're going to select the compute button and get our lower limit and our upper limit. All right, so example 3 for this section is going to be the first one where we're going to kind of walk through this process, right? Instead of just being given the information and asked to make an interpretation based on the information we are given. So in 2013, 2,000 men and 2,000 women were randomly selected for a Pew survey. Interviewers reported that the proportion of men who felt that embryonic stem cell research was morally wrong was 23%, and the proportion of women who felt it was wrong was 21%. We wish to find a 95% confidence interval for the difference of proportions between men and women who feel this way in the population. Right, so we're going to pick something for our two populations. And it doesn't matter which one we pick as long as we stay consistent through the process. So I'm going to go ahead and let our N1 be all American women. And let N2 be all American men. Right, so it doesn't matter again which one we pick as 1 or 2. As long as we make note of it and we keep it consistent throughout our entire problem. So our N1, our first sample size, there were 2,000 women that were sampled. Right? And out of these proportion of women, we had 21%, so 0.21. So there's our P1 hat. Right? N2 was all American men. If we look at this, there were also 2,000 men sampled. Right? And that proportion was 0.23. Right? Our confidence level is 95%. And what we want to know is the confidence interval, which again is P1 hat minus P2 hat plus or minus M. Right? And then as we're looking at these, we want to decide, right, is 0 included? Are they both positive? Or are they both negative? And then we're going to make our interpretation like we did in the last two examples. Right? Again, it is possible to go through this process by hand, doing all of our different calculations. Our standard error formula is really the only thing that changes, but again, we're just going to use Statcrunch as we're working through these. All Right, before we do that, we do want to check our conditions. Right, so population 1, we mentioned, or we assigned, right, as the population of all American women. Right, so the sample is random and independent. We are going to assume that that is true. Right, our number of successes, N1 times P1 hat. So we're going to take 2,000 times 0.21, which is going to give us 420. And 420 is larger than 10. Our number of failures, 2,000 times 1 minus 0.21, and this gives us 1,580. Right? So both of those are larger than 10. Our large population, right? All women greater than or equal to 10 times 2,000, which is 20,000. Well, that's true. There's more than 20,000 women in America. Check our conditions for population 2. So here we are looking for the population of men. Random and independent, yes, we're going to assume that that's true. There were 2,000 men sampled, times 0.23 is going to give us 460. And then our number of failures, 2,000 times 1 minus 0.23 gives us 1,540. And both of these are larger than 10. And then all men greater than or equal to 10 times 2,000 are 20,000. Well, that is also true. So our conditions are satisfied for both of our populations. Now we're going to find and interpret our interval. So as we are using Statcrunch, when we are plugging values in for these, for our N1, right, our N1 is our first sample size. Right? So our N1 is going to be this 2,000. And then our X1 is our number of successes for our first population. So that's going to be 420. Our N2 is our sample size for our population of men. And our X2 is the number of successes for this population. Right? So anytime we are looking for our number of successes, we always take our N value times our P value for that, for each individual population. So then we would go into Statcrunch. We would plug in our N1, our X1, our N2, our X2. We would make sure that we selected a confidence level of 95%. Right? And what we would get for our interval here, right? Our confidence interval, we would get negative 0.045, comma 0.005. So negative 0.045 to 0.005. Right? Our interpretation. We're going to say the confidence interval includes 0. I'm just going to use CI to represent confidence interval. Right? So the confidence interval includes 0. So we cannot rule out the possibility that the same percentage of men and women feel that stem cell research is morally wrong. So since our confidence interval includes 0, we cannot rule out the possibility that the percentages are the same for both men and women. And then I will post an example in Moodle as well that shows kind of the different steps to go through on Statcrunch as far as entering these values and then generating your confidence interval using Statcrunch. So we'll work through one more example. In August 2014, random samples of 2,002 Americans, non-scientists, and 3,748 scientists were asked if the space station had been a good investment for the United States. Of the non-scientists polled, 64% it had been a good investment. Of the scientists polled, 68% said it had been a good investment. So we're going to construct a 95% confidence interval for the difference. Based on this interval, is there a difference in our population proportions? Okay, so again, it doesn't matter what we choose as N1 and N2 as long as we stay consistent. So our first population, we will start with all American non-scientists. All right, so 2,002 American non-scientists were surveyed. Right, and out of these non-scientists, 64% said it had been a good investment. So we have 0.64. All right, population 2 then is going to be all American scientists. Right. We're told that 3,748 scientists were sampled. And we're told that out of these, 68% or 0.68 felt that it had been a good investment. Okay, our confidence level, we're told, is 95%. Okay. And what we want to know, again, we are looking for the confidence interval. The confidence interval P1 hat minus P2 hat plus or minus M. And then once we find that confidence interval, right, does it include 0? Or are they both positive or both negative? Right? And what does that tell us about our conclusion? All right, so population 1. Population 1, we established up here, were non-scientists. So we're going to assume that our sample is random and independent. Our number of successes, we're going to take 2,002 times 0.64, which is going to give us 1,281. And then our number of failures, 2,002 times 1 minus 0.64, which is going to give us 721. Both of those are larger than 10. And all non-scientists is going to be greater than or equal to 2,002 times 10, which is 20,020 people. And so our third condition holds for our first population as well. Right. For our second population, again, we're going to assume that our sample is random and independent unless we are told otherwise. N2, if we go back up top here, right, we're using now this data. So our N2 is 3,748 times 0.68, which gives us 2,549. And then we're going to take 3,748 times 1 minus 0.68, and that's going to give us 1,199. Both of those are larger than 10. all scientists, greater than or equal to 10 times 3,748, 37,480. Yes, that condition also holds because there are more than 37,480 scientists in the United States. Okay. All right, as far as the values that we're going to enter into Statcrunch, N1 is our 2002. X1 is our number of successes, which is 1,281. N2 is 3,748. X2 is this 2,549. Right. Our interval. Right. If we enter this into Statcrunch and we select compute, we get negative 0.066 to negative 0.014. All right, so looking at this then, our interpretation, right, we do not include 0. Right? So we're going to start by saying underneath here, the CI, the confidence interval, does not include 0. So there is a difference. Since both values are negative, right? Trying to figure out the best way to kind of fit this in here. We'll say since both values are negative, P1 is less than P2. Right? So if both values are negative, that means that our P1 is smaller than our P2. Right. And then we can also get a little more detailed here, and we can say the proportion of non-scientists who believe it has been a good investment is less than the proportion of scientists. The plausible difference is between 1.4% and 6.6%. So P1 is less than P2. Our proportion of non-scientists who believe it is a good investment is less than our proportion of scientists. And the difference is our two different percentages that we get for our limits, between 1.4% and 1.6%.